Hi guys, welcome. Sorry I couldn't be here with you today in person to do this, but this is the next best thing. Real quick, this is going to be a pretty short video because we're just going to talk about one thing, and that's graphing intercept form. We already talked about how to graph vertex form last week. We talked about how to graph in standard form when we were together on Tuesday. And today we're going to talk about how to graph in intercept form. This is the third and final form that we'll be graphing from. This is what the parent function for intercept form looks like right here. Okay? We still have an a value. This still tells us if it's positive if it opens up, or negative if it opens down. It still tells us if it stretches, if this number is larger than 1, or it shrinks if this number is between 0 and 1. But what's new is now we have two sets of parentheses, x minus p and then x minus q. These two sets of parentheses tell you where this parabola crosses the x-axis. Okay, so the intercepts here are at P and Q. For example, if you had this equation right here, y equals x plus 2, and then in quantity over here, x minus 3. Okay, we want the opposite of these values here. So this would be negative 2, and this one would be here, positive 3. That's the point on the x-axis where the parabola would cross. So one point would be right here at negative 2, and the other point would be right here at 3. Okay. The axis of symmetry is halfway between P and Q. And the way we can find that is by taking the average of P and Q. What we'll do is we will add P, we will add Q, and then we will divide by 2. So up here, if we had done negative 2 and 3, we would add these two values together. So 3 plus negative 2. So 3 plus negative 2. You have 3 and you take away 2. You're left with 1. So 1 divided by 2. Or 1/2. That would be exactly halfway between these 2 points. The reason that's important is because that is how we're going to find our vertex. Just like we did with the standard form when we did negative b over 2a, we're going to use this to find that point. And I'll show you that down here in just a moment. If the graph opens up, that means a is larger than 0. Right? Which means it's positive. The graph opens down if a is less than 0. That means that is negative. Okay. So we have two sample problems right here. I'm going to do the first one for you, number 16, and then we'll do the number 17 together. So the first thing I'm going to look at here is any information that I can find just by looking at this equation before I even start to graph. And the two things that I can figure out first are here and here. Okay. The one piece that tells us if this is going to open up or down is right here. Okay. That negative 2. That negative 2 tells us that it is going to open down. Opens down, right? Because it opens down, looks like this. Then that makes this part right here, the vertex, that makes that a maximum. That is the highest point on this parabola. Now we can find what the intercepts are, we can find what the vertex is, and then we can plot it. And so the way we find what this intercept is here is we take this value, x minus 1, okay, and we set it equal to 0. So something minus 1 equals 0. Well, that something is going to be 1. That means that there is an intercept right there at 1, 0. And then we'll do it with this parenthesis right here. This is x minus 5 equals 0. So something minus 5 has to equal 0. Well, we'll add 5 to both sides. And so x equals 5. And that is our other intercept, Okay, whatever this number is here, this is 5, right? This is 5, and then the y value is 0, because we're looking at how high on the axis we go for the intercept. We don't go up and we don't go down. The intercept is here at 0, so this is going to be a 0. And over here at 1, okay, we go over 1, but we don't go up or down. We just go over left or right. So the other one is at 5, right there. So 1, 0, and 5, 0. Now our vertex can be found by taking P, this one is P, and Q, this one is Q. We're going to add them together, divide by 2. 1 plus 5 divided by 2. Well, that's 6 divided by 2. And 6 divided by 2 is 3. That tells us that our vertex is at 3 something. Now that we have our x value, we can substitute it here and here, evaluate this side, and that'll give us our y value. Okay, let's see if I can squeeze this in right down here. This is then -2 right here, okay? And then we get 3 minus 1, and then 3 minus 5. So anywhere there's an x in here, I'm going to plug in this value of 3. So this is -2, 3 minus 1, that's 2, and then 3 minus 5, that's -2. So now I'm going to multiply 3 things together here. You can only multiply 2 things together at once, so pick 2, multiply those, then take that answer and multiply it by whatever's left. I'm going to pick these first 2 right here. This is -2 and 2. I'm going to multiply these 2. And that gives me -4 times -2. And then -4 times -2 and negative times negative is always going to be a positive. So this becomes 8. So my vertex here is at 3, 8. Okay, so I'll go over here to 3. 1, 2, 3. And then I'll go up to 8. 2, 5, 6, 7, 8 right there. Typically, we would have to do 5 values in order to find what this parabola looks like. But because we have these 2 intercepts and the point in between as the vertex, we can actually get away with just doing 3. So once we have these, we'll connect them like this. Okay. Now what we know is we know that this opens downward, which this parabola does. We know that our vertex is a maximum. It's the highest point, and that's what that is right there. The 2 other pieces of information here are domain and our range. Our domain is going to be all real numbers. We can put in whatever value we want in here for R, for domain, excuse me, and but we get this R, this all real numbers. And then our range, like we did in standard form on Tuesday, it's Y, okay? And then we take this value here, right here, so that's 8. Okay. And then we're looking at, are we dealing with numbers that are less than or equal to 8, or numbers that are greater than or equal to 8? And as we look right here, we can see that this starts to go down right here, and so we're dealing with numbers that are less than or equal to 8. 8 is the very highest this will be, less than or equal to. Make sure you put the less than or equal to sign, not just less than. Okay, so that's how we do that. That's how we find what the graph looks like in intercept form. Got one practice problem here for you guys. That's this one down here. Move this right here, see if I can get both of these in here at the same time. I think I can. Sweet. Okay. Here's our problem. It says y equals, and then 2 times the quantity x minus 1, the quantity x plus 3. These 2 pieces I can figure out right away, because I'm looking for this value, this a value, and that'll tell me, does this open up or down? Well, this is a positive number, so this is going to open up. Okay? Because it opens up, that makes this a minimum value, because the open up looks like this, and the vertex would be down here. That's the smallest value, so that is the minimum. We could probably jump ahead because you know the domain is going to be all real numbers, so we can go ahead and plug that in if we want. But next we're going to find the x-intercepts. Okay, like we did up here, we found the intercepts first, and then we were able to find the rest of this information. So we're going to find the intercepts first, and then we can find the vertex, and then the axis of symmetry. We'll take this value and set it equal to 0. So x minus 1, we'll make that equal to 0. We'll add 1 to both sides, and we get x equals 1. So that is one of the intercepts. It is 1, 0. And the other intercept is going to be something 0. And to find that, we'll take this value, set it equal to 0, x plus 3 equals 0, and then solve. We'll subtract 3 right here. Okay, this cancels out. We're left with just x on this side, and then 0 minus 3 gives us negative 3. So that is our other point, negative 3. We can take 1, 0, put a point there. This is over 1, up 0. Okay, our intercepts are always going to be plotted on this line. Your intercepts should never be up here, down here at all. Okay, it should always be on this line. And then negative 3, 0. 1, 2, 3 backwards, and then 0 right there. Okay, so those are our two. The last piece we need is our vertex. Once we find the vertex, we can figure out where this is going to connect. In order to find the vertex, we need to find this x value right here by doing p plus q divided by 2. Well, here's p. This one's p. I'm going to go p. Okay. It doesn't look like p. Let me try to write a p. That's going to bother me. P. This one is q. Okay. Now, they could interchange. This one could be q. This one could be p. It really doesn't matter. But the first one we wrote right here is going to be p. The second one we wrote is going to be q. We're going to add these two values together and divide by 2. So we'll do negative 3 plus 1 and divide it by 2, because that's what we do up here. Negative 3 plus 1, so you owe me 3. You pay me 1, you still owe me 2. So that's negative 2 divided by 2. And then negative 2 divided by 2, that equals negative 1. Okay, that means our vertex right here is negative 1 something. Before we find the y value here, we can also finish up this axis of symmetry. Remember what we talked about on Tuesday, that this value here is the axis of symmetry. But we're not just going to put negative 1 as our answer. We have to put x equals negative 1. We're going to put negative 1 into x. We're going to substitute it to find out what this value is right here for our vertex. So it's going to be 2 times negative 1 minus 1, and then negative 1 plus 3. Negative 1 goes in where these x's were. Negative 1 minus 1. You owe me 1. You owe me another 1. You owe me 2. Okay. This is having 3 plus 3, and then taking away 1. That is 2. 2 times negative 2 is negative 4 times 2. 2 times negative 4 is negative 8. So this is negative 8 right there. Okay, so our vertex is at negative 1, negative 8. So negative 1, 2, 3, 4, 5, 6, 7, 8 right there. Okay. We'll connect these up like this. And then we'll do our range. We know it's y, and this is our value here. It's going to move down into our range. So that's a negative 8. And then we're looking at, are we using numbers larger than negative 8 on this graph or less than negative 8 on this graph? And we can see that the line for negative 8 is right here. I'm going to make my pencil flat right here. And we're using all these numbers above negative 8. So it's greater than negative 8, greater than or equal to negative 8. This stuff is all very similar to what we did on Tuesday. The only difference being here now is instead of using negative b plus 2a to find our x value, we're using p plus q divided by 2 to find our x value. Okay? And then we also only need 3 points to graph instead of needing 5 points. Okay? So that's that. We have an assessment next week. So if you need to relook over this at home, this will be uploaded onto the Canvas calendar, so you can go up there and you can rewatch it should you feel the need to. Otherwise, I have some practice problems for you guys to do in Vertex, Standard, and Intercept Form to make sure that you're feeling all right. When I come back with you on Monday, we'll talk about any questions you guys had, anything that I can clear up before your assessment, which right now is scheduled for Wednesday. Okay. If there's anything else you need, you know how to get a hold of me. Otherwise, I'll see you guys on Monday.